Hello everyone, and welcome to Algebra 2, Chapter 7, Lesson 4, Properties of Logarithms. This is video 2, where we will be discussing the inverse properties of logarithms and exponents and the change of base formula. So let's see what those inverse properties of logarithms are. Okay, the first inverse property that we have to look at is log base b of b to the x equals x. Okay, now what it says is if this base matches this base, then your answer is just going to be x. And it's related to that power property of logarithms that we looked at in our first video. Let me show you how that works. So if you use the power property to take the exponent and move it to the front, you get this. And then log base b of b. So it's saying b to what power is b? Well, that's b to the first power is b. So really this is x times 1, which is x. So that's where this comes from. It comes from that property. Now, we also have something that's very similar, but with exponents. This is b to the log base b of x equals x. And this one isn't as clear why it is, but just know that if this base matches the base on your logarithm, they will cancel each other out, and you're just left with the x. So let's see some examples where we're going to need to apply these, and we're going to need to simplify some logarithms. In example 4, it asks us to simplify each expression. So I would encourage you to pause the video and try these, or just keep the video playing. In the first one, notice our base matches our other base. So they will cancel each other out, and the answer is just 3x plus 1. In the second one, you can just use logic to figure this out. You can say 5 to what power is 125, or you can rewrite this 125 as a power of 5. So it's up to you. 5 to the third power is 125, or you can do this work. Okay, so 125 is 5 to the third. These 5s, the log base 5 and this 5 here, will cancel each other out, and you just get 3. Now in part C, notice this base of our exponent is the same as the base on our logarithm. So they will cancel each other out, and you just get 27 for that one. Okay, so this equals 27. Now, next, we're going to take a look at a change of base formula. This formula can be used to change any logarithm into a different base logarithm. Okay, and you get to pick whatever base you like for this. So if you don't like the base that they've given, like maybe this is log base 4 of 25, well, I don't know what 4 to what power is 25. So maybe you can pick a different base that maybe you do know the answer to. So you get to pick whatever base is here. And now notice, if you were writing this on a lined piece of paper, there would be a line right here. Okay, and the x would be on the line, and the b would be below the line. That's how I remember what goes above and what goes below. So it's log to whatever base you want of the big number over log to whatever base you want of whatever the base used to be. And you can use this to simplify logarithms. And you can also type it into your calculator as long as you pick the common log or the natural log as your base. So let's take a look at an example where we have to apply this to simplify an expression. We've been asked to evaluate the logarithm using the change of base formula. And they've given us log base 4 of 8. Now, you probably don't know what power of 4 would get you 8. But what we do know is that both of these are powers of 2. So what you can do is use the change of base formula and do log base 2 of 8 over log base 2 of 4. Let me show you and simplify it to get the answer. So log base 2 of 8 is 3, and log base 2 of 4 is 2, because 2 to the third power is 8, 2 to the second power is 4. And then 3 over 2 is just 1.5. Now, it's not always going to be this way. They won't always be powers of the same number. So what you can do is just use the common logarithm and type it into a calculator. The common logarithm is log base 10, and I just typed in log of 8, and there's a log button on most scientific calculators. And then I made sure to close the parentheses on mine, because mine shows parentheses, and I have to close them. and I hit divided by log of 4, and it gave me about 1.5. So that is how you would use the change of base formula to evaluate a logarithm. I hope this video was helpful. Let me know if you have any questions.